are doing that this week, I'd like to encourage you to take some time to go back and work on coming up with some definitions. Go back and review some different concepts. Okay? Getting ready, we need to do a test of the material that we've covered kind of since we got back from break. And this will be in a couple of weeks before we do this. I think we're going to do this in 2 weeks. So it's not going to be right now, but you might want to go ahead and start kind of looking at some of these things. So you can just have a bit of a review there. Hold on just a second. I'm trying to shuffling around here, trying to find what I wanted to talk to you about also. Okay, going back and thinking about the definition of a pentagon. All right, pentagon. You've got that, the idea of what a polygon is. Remember that polygon, we're going to have all of our sides. They're going to be angles. They're going to be connected. They're going to be closed. Okay, and how many sides does a pentagon have? Okay, yeah, that pentagon's going to have those 5 sides, right? Oh, kind of like a house. Except that generally they're going to be drawn in a little more at an angle, right? Okay, so the idea of a pentagon, a regular polygon with 5 sides, 5 angles, 1, 2, 3, 4, 5. All right, remember how that's going to work? All right, the side opposite the right angle in a triangle. What do we call the side that's opposite the right angle in a triangle? All right, so as you could read that definition, you could draw yourself out a right triangle, and you could look at what do we call the side opposite that? The hypotenuse. Great. All right, think about if I have a circle. All right, and we take out this right here. All right, what do we call that? What do we call that area? Okay, it's going to be a sector. Okay. Going back and remembering that. All right, think about this for a second. A solid with lateral surfaces that are parallelograms and 2 parallel bases. A solid with lateral surfaces that are parallelograms and 2 parallel bases. All right, so I've got a solid. Okay. All right, here's a solid, lateral surfaces. Get back and think about what's it mean to be lateral? And you can go and look in your dictionary at the back if you're trying to think of what does lateral mean, and you'll find it's not in your glossary. All right, so let's go and look and see what does the word lateral mean as we're trying to think about what is that definition asking us for. Hold on. All right, something that's lateral of, at, toward, or from the side or sides, a side part of something. Okay, so looking at the laterals are going to be our sides. All right, so we've got this definition. It says a solid with lateral surfaces that are parallelograms and 2 parallel bases. So here's my 1 parallel base. Down there is going to be another parallel base up, up underneath here. Here are going to be my parallel sides. They are this we've got one here. I've got one on the back over there. I've got this one here. I have one on the back over there. All right, so those are going to be my parallel sides. All right, with this being a solid. Okay, there's the idea that this is going to be a prism. All right, that solid is going to be a prism. All right. Next thing to think about is what's the definition? If I'm looking at a solid, okay, no, hold on a second. Any quadrilateral with 4 sides congruent. Any quadrilateral with 4 sides congruent. All right, what is a quadrilateral? All right, we have that idea of lateral, which the lateral is going to be those sides that are parallel to each other. We've got so I've got my quadrilateral and the quad telling me there's 4 of them. Okay. Remember, this is a rectangle. It's also a rhombus. If we look back in your book, which lesson had that for us? All right, let's go back and look for just a second at lesson 11. Okay. Lesson 11 had this idea of the polygons in it. The word polygon comes from two Greek words, polis, meaning many. We've got the many angles in there. Okay, so this is where you're going to see the idea of the regular polygon, a polygon with all the sides are congruent. Remember, congruent, equal length, equal angle. All right, so we've got that going on there. All right, remember here we want to look at a flipped over page. We've got the pentagon, the hexagon, the octagon. Okay, seeing those equal angles that are within all of those. All right, let's see. There was also, there it is. Sorry, I'm looking for the chapter where we did have all of that defining. All right, I'm going to move on for you guys because I can't find exactly what I'm looking for. So we'll let it go. It'll be fine. Go over and make sure you look there at lesson 14. You've got this idea of a volume of a rectangular solid. Okay, we've got our different faces, edges, vertices. Oh yeah, last week we talked about how do you find the vertices. Looking things up, I could never find a formula. All I could find is that you really just have to count them. For just a second, I'm looking at lesson 14. It says, I'm in the second paragraph. In this lesson, there are several new terms that are used to define the shape in a figure. That flat surface, in figure 1, the flat surface rectangles that make up the rectangular solid are called faces. Okay, so looking at that figure that you're seeing there, they've got, all right, those are going to be your faces, right? Boom, 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 boom. All right, so those are going to be your faces. Where the lines of the faces meet, those are going to be called edges right there. All right, and the points where the edges meet right here, those are going to be our vertices. All right, this solid has 6 faces, 12 edges, and 8 vertices. And like I said, we talked about that last week. How do you figure out how many those are? You really just have to count it. I never was able to find anything to help us out with figuring that out at all. But go back over, remember how we find the volume? There was the idea of needing to get the area of that base. And the area of the base is just going to equal the length times the width. But then when we do the volume, we have to consider the height as well. So the volume equals the length times the width times the height. Or we can look at the idea of the area of base times height. And that volume is equal to the area of the base times the height. Okay, you're going to do the same thing when you look at a cylinder. Okay, so with a cylinder, remember that you are also going to want to determine what is the area of the base. Remember, that's going to be a circle. How do we find the area of a circle? Okay, pi times the radius squared. Okay, so whatever my radius is, say that it's 3. Okay, that area is going to equal that. And then I need to take it and multiply it by whatever the height is. Okay, so the volume is going to equal the height times the area of the base. Again, same thing. Okay, so the volume is going to equal the height times pi times the radius squared. All right, so make sure that you go back over that you feel good about that. We've then got lesson 15. this is here where we have the idea of the volume of a pyramid and a cone. Okay, so just flipping back through that real quick. They've gone through some of the definitions for you. See there, I'm looking lesson 15, looking at the idea that there's that base down there on the bottom of it. All right, they're showing you that. Theirs looks a little more slanted than mine does, probably. A little more like that. That's the base that pyramid is going to be built on. All right, so we get that area there, and then we've got coming up here our different sides. Okay, but then the idea that right smack dab in the middle of it is going to be that altitude. All right, but then over here, if you can think about the fact that here on the side, we have this triangle right here on the side, right? All right, well, it's going to have a height as well. All right, and that height on the side is going to be our slant height. All right. Let's see how we're doing time-wise. Make sure I keep you guys engaged. All right, so that's how that's going to work. All right, so coming back over here, now I've flipped to the next page. Remember the idea of finding the volume of a pyramid with a square base. They have 1/3 times the base times the height. All right, so looking 1/3 times the base times the height, they have, so they've got their base, and the base is 5 by 5. All right, volume equals 1/3 base times the height. All right, my base is 5 by 5, so that's going to be 25. All right, when I look in here then, they give me this right here as that altitude. There's the idea that there's all of those various triangles that are meeting right there in the middle, right? All right, but this right here is coming from the center of that base going up to that very center right there, and I know now that that's 3. All right, so I've got that. And then I'm going to take 1/3 of that. Okay, thinking about if I had a solid, my base is 5 by 5, okay, and as I come up here, probably was a better way to go about drawing this than what I just did. All right, so say I've got this solid right here, okay, and it's going to be 5 inches by 3 inches. If I took that whole thing, I would get that, remember finding the volume of the cube? That volume equals length times width times height. So it'd be 25 times 3, where the volume of that whole thing would be 75. Okay, where this right here, the volume of that pyramid is going to equal 25 times 3, be 75 times 1/3. It's just going to bring it back down to 25. Can you see the idea that this pyramid fits inside this cube? All right, so what we wind up having when we look at what's the volume of this pyramid, the volume of this pyramid winds up being 1/3 of the cube that would be made if we took that base and brought it all the way up.